This is a Yee diagram, and I'm going to explain how it works. And basically, in one sentence, it's a map of who wins an election. So let's start off with the basics. Let's take away the Yee diagram, start with one voter, and use three candidates, 1, 2, 3. The voter votes for who he's closest to. Anywhere in this region votes for yellow. So in a Yee diagram, that's colored yellow. Same for red and blue. You can do this for the winner of an election with many people. So all these people vote, and they vote for who they're closest to. And red, they got 21. They get eliminated. I mean, they don't win. So it's actually there's no place where this center of the voting population can be where red wins. Blue wins when the center is over here. Yellow wins when the center is over here. So that's kind of a problem if the center of the voting population is centered directly on the red candidate and red doesn't win. It's kind of a problem. At least it's a problem with first past the post voting. If you have a Condorcet system, then you don't have a problem. It's pretty much the same as, just a single person voting. So Condorcet is a lot better. But with first past the post, there is no region where red can win. So even if the voters get really close to red, they don't win. So that's what this Yee map shows. You can also make a Yee map for each candidate. So let's look at the red guy since he's having trouble winning. So let's put the voters right in the center. And let's kind of trade places with the red guy. So in this situation, red can win if the voters move over to red. Now, let's look at this from the perspective of red. Because red might want to move might think he wants to move towards the center, but in reality, if red moves towards the center, he does not win. There's really no place for red. This is a map of who wins the election, and with red at each pixel. So let me make that more clear with one voter. So here's one voter. He votes for whoever he's closest to. So if he's closest to red, then red wins. So if red moves into this circle, then he wins because he's closest. You can see this is a circle. By upping the resolution a little bit. There's a similar circle for yellow and blue. So blue has this winner circle. So if we apply this kind of idea to that situation where red had no chance of winning, let's see what happens. So that's interesting. Did I do that right? So red is winning in this area. You know what? Forgot to move these guys back. Okay. So red is has no chance of winning, no matter where he goes. And what's even worse is that if red moves over to yellow, then he causes yellow to lose. Blue wins in this region. And vice versa. So red is spoiling the election for yellow. Red's the spoiler. So Yee diagrams, just to sum up, they show who's the winner. So you can base that on the movement of any one of these guys. So you can be based on the movement of blue, based on yellow, based on red, and you can also have based on the center of the voters. So this is the Yee diagram I saw when I first encountered Yee diagrams. They're named after copying Yee. That's the namesake of the Yee diagram, and you can see the images he made. He didn't make any that were based on candidates, he just based them around voters. So I kind of extended that with this simulation. And so this is just a word explainer saying what a Yee diagram is and how you can see basically what's happening in an election with a Yee diagram.